Introduction. Lightning is a spectacular natural phenomenon which is caused by electric charge. Here we see it in the sky over Kuala Lumpur. Suggest some other examples of phenomena due to electric charge. If you hold your hand close to the television screen and get somebody to switch on the TV, the hair on your hand stand on end. When you take off your polyester t-shirt, you can hear cracking sound. If you rub an inflated balloon in your polyester t-shirt, you can make it stick to the wall. In this lesson, you will learn Coulomb's law, electric field due to a point charge, electric field due to several point charges. There are two types of electric charges, positive and negative. In this interactive model, we see two charged particles and the forces acting on them are represented by the vector arrows. Use the model to explore how the type of charge relates to the force. The model allows you to choose the type of charges between positive and negative. You can also drag the particles to new positions and observe the forces between them. For each of these pairs of charges, select whether the force is attractive or repulsive. What can you conclude about the type of force between like charges and that between unlike charges? Answer: the force between like charges is repulsive, and between unlike charges, the force is attractive. Two positive point charges Q1 and Q2, initially of 1 Coulomb, each are separated by a fixed distance. The electrostatic force on each charge is F. Move the slider to change the charge of Q1 and Q2 and observe how the electrostatic force on each charge varies. If the distance between the 2 point charges is fixed, how does the electrostatic force between the 2 point charges vary with the magnitudes of the charges? Answer: the force between 2 point charges is directly proportional to the product of the magnitudes of the charges. The 2 point charges Q1 and Q2 are initially at a distance of 1 meter apart. The force between the two charges is 1 F. Move the slider to change the distance between Q1 and Q2 and observe how the force between the two charges changes. What can you deduce about the relationship between the electrostatic force and the distance between the point charges? Answer: the force between the 2 point charges is inversely proportional to the square of the distance between the charges. Coulomb's law relates the electrostatic force F between 2 point charges to the magnitude of the charges Q1 and Q2 and the distance r between the charges. Click on the next button. Coulomb's law can be expressed as follows. The electrostatic force between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Drag the test charge Q away from the charge Q and observe the graph showing the variation of the repulsive force F on Q with distance r between the charges. Change the charge Q to negative and observe the graph of F against r. The force between the positive Q and negative Q is negative because it is in an attractive force. Coulomb's law in electrostatic is similar to Newton's law of universal gravitation. Both forces are inversely proportional to the square of the distance between them. The magnitude of each force is proportional to the product of the charges or the product of the masses. Gravitational force is always attractive, whereas the electrostatic force can either be attractive or repulsive. Consider a proton and an electron separated by a distance r. There is an attractive electrostatic force between the electron and proton due to their unlike charges. There is also an attractive gravitational force between the electron and proton due to their masses. What is the ratio of the electrostatic force to the gravitational force between the electron and the proton? Click on each force to see the calculation. What do you conclude? Answer: the electrostatic force is very much greater than the gravitational force. Summary. Coulomb's law. The force between 2 point charges is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance between them. F equals 1 over 4 pi epsilon naught Q over r squared. Both the electrostatic force between 2 point charges and the gravitational force between 2 point masses obey the inverse square law. The electrostatic force between an electron and a proton is very much greater than the gravitational force between them.